All right, hi guys. Today we're doing 9.5 day 2. We're going to continue looking at the normal curve, our empirical rule like we talked about last time, and figuring out some different probabilities. So at the top here it says, remember, the empirical rule of the normal curve helps us determine the probability of certain data points within that distribution. Okay, so it can help us figure out like how much of the data is between certain values or above or below a certain value, things like that. So quick review of what we just did in the last lesson. We're going to fill in our normal curve here with our appropriate percentages. Okay, so this is just coming from our 9.5 day 1 notes. So on the left here we have 34% on each side. That's between 1 standard deviation above and 1 below. And as we move out, our percentages will get smaller. And then this little tiny one is 0.15. Again, I like to think of a distribution of height as the easiest example because it's so clear when you think about it, like, oh yeah, most people are about average and not very many people are very, very short or very, very tall. So we have 13.5 next. And then 2.35. And then again, our very, very small section is 0.15%. This is anyone bigger than 3 standard deviations above the mean on the right side here. So remember, the mean goes in the middle, and then we add standard deviations to the right and subtract them to the left. So let's look at an example again. This is similar to what we did in the last set of notes. Just quick review here. Here now we have some context to this problem. It's not just random numbers. It says test scores are normally distributed with a mean of 76 and a standard deviation of 10. Okay, so we're going to start by labeling our normal curve to model this distribution. So let's think about where we're going to put the mean. So we'll put that right in the middle here, 76, and then as I move to the right, I'm going to add a standard deviation, so 86, because our standard deviation is 10, and then 96 and 106. Okay. As I move to the left, I'm going to subtract standard deviations. So subtract 10 to get 66, and then a score of 56 and 46. So thinking about just like your class, most people score around the average. Very, very few people are going to score way up here at 100%, and very, very few people, hopefully, are going to score down here. Okay, so we can figure out probabilities that if I were to just pick a random test score from this group, what probability it would be that they're above or below certain scores, things like that. So part A, it says what is the probability a certain student scores above a 96? So before I do this, what might be more helpful is to label those percentages so that I don't have to like think back in my head. I can just see them right on the paper here. So we have 34, 34, 13.5. You're going to write these down a ton throughout this unit. And then 0.15. So if I'm looking for anything above a 96, I'm going to start by finding 96 right here. So that would be anything above 96 is going to be to the right. And remember, I'm adding those percentages. So 2.35% plus 0.15%. And that gives me a total percentage of 2.5. But remember, we're looking for probabilities, so we don't leave them as a percent. A probability is written as a decimal. So as a probability, this would be 0.025 because we move our decimal 2 spots to the left. Okay. Part B, what is the probability a student scores below a 66? So for a student to score below a 66, I'm going to find 66, and I'm going to add up all the numbers below it, all the percentages. 0.15% plus 2.35% plus 13.5% to get 16% as a decimal 0.16. Okay, I'm showing you guys all of the methods using just addition because that works in every type of question. Some of you might start to find other methods using subtraction, thinking about like, okay, well, this is 50% here and things like that. That's totally fine. As long as you're getting to the right final answer, if you have a method that works better for you, I'm fine with that. Okay, so I want you to try C and D on your own here. All right, here are my answers for C and D. If you want to pause the work to look a little bit more closely, you can. But I got 0.84 for C and 0.815 for part D. Okay, so let's look at one more example together. It says, in the figure, the shaded region represents 47.5% of the area under a normal curve. What is the mean and standard deviation of the normal distribution? So we're basically just working backwards here a little bit. We have some information on our normal curve. So if I look at the picture, I have a value of 13 and a value of 16. Now I know that the jump between each section is the amount of the standard deviation. So to get from 13 to 16, let's think about how much I add there. Added 3. So I know that that tells me my standard deviation. So I'm using the symbol sigma. You can write the word standard deviation, that's fine. But my standard deviation equals 3. Now I need to find the mean. So let's think about where the mean is on the normal curve. Okay, so the mean is right in the middle. So I just need to move one more to the left. Now, when I'm moving to the left on the normal curve, I'm going to subtract a standard deviation. So 13 minus 3 gives me a mean. So again, here's my symbol, 10. You can write the word mean, that's fine. Okay. Now, and that's all I had to do here because it just said what does it mean, standard deviation. This 47.5% is kind of a distractor. So it doesn't really help us answer the question in any way. So the last part I want you to try. This is very similar to the problem we did at the beginning. The one thing I'll point out here, you're looking for the percentage, so you can just stop once you get the percentage. You don't have to convert it to a decimal, okay? So here you can see all the questions at once. You'll want to draw and label your normal curve yourself, and then I'll leave the questions here so that you can see them as you answer. All right, so taking a look at these answers here, first I'll just show you my normal curve. Again, the mean is in the middle, 106, adding standard deviations to the right, subtracting them to the left. Using that normal curve and the percentages I have in blue, here are my final answers. Feel free to pause again to look more closely at my work and see how I added up the values. You will find as you do more of these, you get the same answers a lot. That's fine because you're only working with the same set of numbers, same set of percentages, so you get repeat answers a lot.